שזה לא עשיתי את זה 4-3.
זה 3? למה זה נראה יותר?
לא, זה...
זה 4? רק 3.
Are you filming it for
מה שלא למדתי כימיה.
לא
לא, למדתי עד כיתה י"א, אבל בי"א לא אהבתי את זה, כי זה היה כימיה פיזיקלית.
זה
מול,
מה שאני הכי אהבתי.
לא, מול ו-PVNRT, כן,
That's my
וכזה,
favorite
minus
part.
log H plus is minus log
נגד
PH.
You know, Imba
כן,
recorded
זה minus
the
log
speech.
של זה.
לא, אני...
She recorded all the speeches. It's
ואז
so
הסבירו לנו שהשמפו חומצי, ובסיסי.
exactly that's why it's funny,
They
Michael.
really were.
The last one was so
זה מה שעשיתי, אתה יודע,
Only people.
עכשיו אנחנו עושים טור.
No,
טורי
the 14th
טלו.
was
אני אומר,
amazing.
This
was awesome.
לא, אנחנו כבר בטורים.
I don't know.
התקדמנו.
Keep on
Okay,
the first place.
is it on?
It's on.
Does she have to see all how you eating and all that?
For that one, it doesn't see me.
Okay, no, but I mean it's like recording when we're not doing anything.
It's only recording you.
Okay.
You're the only person in the screen.
Okay, can we start?
Yeah. Sure.
Okay, since Shir is not here today, I need another volunteer for the approximation of the calculator. Somebody who would be a calculator man.
Well, I always have the calculator.
Oh, you always have?
Yeah.
Okay. Do you know how to do the sigma?
Yeah.
Okay. It's math 7 or math 9?
Yeah, something like that.
Yeah, something like that. Okay. There's not enough light.
Hello.
Let's
I promise.
I'll keep my hand.
Okay.
let's do some review about the things we know.
Oh. Thank you.
Okay. These are the things that you have to remember by heart. 1 minus x is
Sigma.
1 plus x squared plus x to the n, or in sigma form, x to the n goes from 0 to infinity, and any
Absolute
restrictions?
value of x less than
X
1.
has
Yeah.
to be less than. Yeah.
Like this, okay? This one is the same, just that it's with minus and plus. So it's negative 1 to the n, x to the n goes from 0 to infinity, and also for the same thing. I'm not writing 1 minus x squared and x cubed because this is something that you, like for example, I wouldn't write sine of 2x because if you know sine x, you plug in 2x. Okay, e to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial and so on.
Why are you not writing the sigma first?
No, I want this, and this can be the sigma of x to the n over n factorial. Because if I wrote the sigma first, you would say, why didn't you write this first?
Because you derived the sigma from the sigma.
No, it's both. It's just another way of, this is the way of what it is. The sigma is a short for that, okay? The sine x, let me put, we didn't learn anything. I mean, the invert, hyperbolic sine, hyperbolic cosine was just to show you. You don't have to memorize it for the test because it's not in the material. So that was just like
A bonus.
sine x, yeah, it's a bonus. It starts with 1 or with x? What do you think?
Sin x is negative
Always,
1.
it's always X.
Always x because it's an
It's
odd
odd function.
function. Very good. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Or in sigma form, n goes from 0 to infinity.
Negative 1.
Negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Cosine of x is?
It's the same, but
It's
it's
even.
It's even.
It's
function.
1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And in sigma form, n from 0 to infinity, negative 1 to the n, x to the 2n over 2n factorial. These three converge for all x. There are no restrictions for that. The ln of 1 plus x has a problem.
I thought it was sheer for a second.
את רוצה לשבת
A
להצטרף?
fourth of your Angela's honey gone from you. Me and Emma.
Wait, what?
Because they onions.
You're being recorded, by the way.
Seriously?
Yeah.
Seriously.
By who? Who says
No,
computer?
don't touch it.
It's for sheer, because sheer is up here.
סוודיוש, I love you so much. בהצלחה בללמוד את המתמטיקה שהפסדת היום.
Okay.
I'm taking one for naught, okay?
Okay.
Thanks, Angela. It's really
The
nice.
problematic one is ln 1 plus x. It's good to release some energy.
I thought it was sheer.
This one is a problematic one because it's for the radius of convergence is 1, but the interval of convergence is -1 to 1. This does not include, and this does include.
Oh yeah,
Alright,
we talked about
remember this? Why does it include? Because we have the Leibniz thing on the right-hand side. The left one is the harmonics theory. It turns out to be something like this. For this one, which diverges, and this one turns out to be -1 to the n over n, which converges. Remember why this converges?
Yeah.
Because Leibniz theorem, 1 over n
Yeah, it's
goes
plus
to
minus,
0,
plus minus,
and
plus minus.
it's
Alternating.
alternating, but not enough that it's alternating. Not every alternating converges. But this set, we have two conditions. The an goes to 0 and decreasing. So that's why. Okay, do you remember what ln of 1 plus x is? Do you remember what it is?
No.
Check my notes.
No? Do you want to check your notes?
I don't
I'm going to erase everything and write only ln of 1 plus x here. So today we'll learn
We did
about the ln of 1
I got it. What do we need to know?
What is ln of 1 plus x?
Sigma
Yeah?
Sigma.
n
Sigma.
equals 0 to what?
No, n equals 1 to
Sigma.
infinity. ln of 1 plus x, it can't go from 0 to infinity. It goes from 1 to infinity because I have an n in the bottom.
Oh,
Have a
that's
look.
what I meant.
Okay?
Yeah.
-1,
N, part of n
-1 to the n,
to
x
n to the n.
x to the n over n, like this?
Yeah. Yeah.
and factorial, no?
No, no factorials.
That's the answer.
And that's what it's.
Yeah, and if you write it like
We're
this,
supposed to
Oh,
memorize
people
that one?
are
This
Yeah,
one we have to
yeah.
memorize.
it's also you have to
For
know.
x plus 1? Or
Are you sure it's it's not -1 to the n plus 1?
Aren't you supposed to know?
No, I'm just asking you
My
what's written
notes,
there.
based on my notes, yeah.
Because if x equals 1, it's negative. It's like, it's x minus. Is there an x squared as well?
No.
Are you sure?
I don't know, like on my notes.
Suppose we don't know what it is. I'm leaving this here and erasing it, and we will derive
I'm
ln of
leaving
1.
this here, erasing it.
Yeah, no.
What?
Make any-
What?
I'm leaving it here.
You just erased it.
No, leaving the ln of 1 plus x, and we're doing it, I'm erasing this, we're doing it in another way.
Oh, okay.
That we're going to learn today, and it's called term by term differentiation.
Can we just do f prime of x and double prime of x?
You will see in a minute. It's really
That-
cool. This is another technique that we learn. And if we have, let's say, 1 over 1 minus x,
יש לי שאלה.
כן.
So we know that to find the power series of ln of 1 plus x, we do, the first term is f of 0. F of 0 is ln of 1, which is 0. So we know that it can't start with x, so we know that it's sigma of -1 to the n plus 1.
Don't worry about it.
But
We
is it right?
will do ln of 1 plus x.
If
in
I'm in the
another way.
test and I think that way, is that right? Did I go? Did I
ln
go
of 1 plus x,
the first term in the power series will be 0.
yeah.
Is that
Right,
one?
because-
So it starts with an x.
Because it's on, so it doesn't start with an x.
Why?
Because 0.
Because it's 0, the first term, oh.
Yeah, but
So
0
then
is...
0.
What is the second term? So f prime of, so then we do f prime of 0 to find the second term.
It's going to be x minus x squared over 2.
So it
plus
was right.
x. Yeah, but I will show you another way.
We
Uh,
my equation was right.
You will write the equation in a minute
It's with the water.
after, because the way to derive ln of 1 plus x that you will need to do in the test if you're stuck is not by Taylor, but by trick. And this technique we're learning today, term by term differentiation. And who can guess if there is a term by term differentiation? Probably there is term by term.
Integration.
Right. So let's start with term by term differentiation. Are you going to fit everything into this little page?
It's not little.
Can we get a drink? It's very spicy.
We'll have a break in about 40 minutes.
40?
32.
It's very spicy.
אז הנה, תשתה פה מהמים האלה,
It's
מים
oil.
Drink water.
chemicals.
It's oily. These-
No,
this
it's
is
not
not
oily,
good
it's
water.
chemicals. How about this?
This is
Yeah.
the
Oh,
worst.
take a shower.
When we finish, I'll run in 30 seconds. When we finish,
Okay.
Do the problem.
What is 1 minus x? I'm talking about,
in
if I say we can do term by term differentiation, and I didn't mention it, only in the interval of convergence, because we were not interested when the function does not exist and doesn't have a meaning. So it goes without saying. So what is 1 minus, let's say this one would be 1 plus x.
plus x squared, plus x cubed, plus x to the fourth,
Plus
Plus
x
x to the
to
fifth.
n.
Or in sigma form, n equals
X to
from
the
0 to infinity, x to the n. Okay? So if I take the derivative of each term, the function will be the derivative of 1 minus x. And look what happens. If I take the derivative of 1 over 1 minus x, which is 1 minus x to the negative 1 prime, right?
So it's
Is it?
negative 1.
So it's negative
times
1.
Negative
which is
1.
just-
We did this already.
Yeah.
We never did this.
Oh, we did.
Okay, negative 1 times
We
negative.
took the derivative.
And then negative
No,
1.
because we took the
We
derivative
did
to
for
find
Taylor.
Taylor, but
Yeah.
this is like to find
Oh,
the
So
extension.
then
it's just
negative
1
1.
over 1 over 1
The yeah.
over.
So
minus x
right
squared.
now I know that if somebody tells me find a Taylor expansion or a Maclaurin expansion for this, I will take the derivative of that. Because I took the derivative of the function, so I have to take the derivative of each term. So that would be 0 plus
What?
1.
I don't get what you're saying.
I didn't. What did you do?
Okay, if this is equal to this,
Yeah.
so the derivative of this is equal to the derivative of that, which
Yeah.
is
Oh,
the
yeah,
derivative of
makes
each
sense.
one.
Yeah, yeah.
Oh,
So the derivative of this is that.
but didn't we use Taylor to get to this point?
No, we
To
used
get to the power?
geometric series. Not important. I'm telling you methods, shortcuts. If you need to find the expansion of this, I know what you're. This is not this. I don't mean this. I mean 1 minus x quantity squared. It's two different things.
I know.
Yeah, and this one.
Oh,
Yeah, this you can just plug in x squared here, x squared, x to the fourth, this. But this is different. Be careful. It's
I
1
see.
minus x quantity squared.
I
we
thought
have-
that Taylor allows us to get a power
Taylor
series.
is a long method.
To get us to a power series.
Yeah, but Taylor is
But now
like
we're
you're
using the power series to
Of
get to another
course.
power series.
How did I use e to the 3x? I know that e to the x is x to the n over n factorial, and I have to memorize a few things and then move on with it. It doesn't mean that I have to do everything from scratch.
I understand.
If I have e to the 3x, imagine you have e to the 3x, and you're going to do Taylor. 3e to the 3x, 9e to the 3x, and then do everything. Instead of like knowing e to the x and plugging 3x instead.
Okay.
So this method is like, I know this is in the list of those that I need to know.
Fine.
And through them, I'm building up my library functions, okay? So I'm taking the derivative of that, which happens to be 1 minus x squared, and I'm taking the derivative of each term. So the first term falls, the next one is 1. What's after 1?
2x.
2x plus 3x squared plus 4x to the third plus. So this is going to be nx to the negative 1. N goes from 1 to infinity. I can write from 0 to infinity, but 0 would be 0 anyway, so we usually do from 1 to infinity.
Okay.
So look, I didn't do much, and I got the Taylor expansion of this. The Maclaurin expansion, just like that, just by taking derivative of something that I know,
Okay.
right?
You didn't even have to do the.
Yeah, but you were creative. You knew that 1/1, like you know that.
I know because it's in the list of the 6, 7 things that I need to know. I can use the sine x, cosine x, ln of 1 plus. I don't even need to know ln of 1 plus x, and I show you why.
Yeah.
This one is not. It's good to remember it, but if you don't, it's not a big deal. You have to know e to the x, 1/1 minus x, sine and cosine. That's all. All the rest you can do through these.
Yeah.
By differentiation, integration, by tricks,
Also
by...
ln. Did you say ln? We need to know ln.
No.
We'll derive it.
If you know, it will save you time, but if not, you can derive it easily, and this will be
So are we gonna
later on
derive it
today.
now? Okay.
But this is the first thing. So here, we find 1/1 minus x squared just by taking the derivative. Let's take second derivative. So
this
now,
will just be n
Maybe
minus
we'll
1.
find something interesting.
Isn't it n minus 1 n x to the n minus 2?
Yeah, look, if somebody tells me, find the derivative, the expansion of this.
Okay.
So I know that if I take second derivative, there will be constants or something. So here is what we do. Let me erase here. Can I erase this here? Did you copy? Okay, she says yes. Okay, so let me just write it down here. The second one. 1/1 minus x squared. Needless to say that the same radius of convergence. And that would be the derivative of that, which is 1 plus 2x plus 3x squared plus nx to the n minus 1. And it is from 1 to infinity, and x to the n minus 1. Now my task is to find a Taylor series, a power series of that. So
Is that-
if I take
But
the
that's not the second derivative, is it?
that's not the second derivative, but there will be something like this with constants. But
Okay.
let's see. If I take the derivative of 1 minus x to the negative 2, the derivative would be negative 2 times 1 minus x to the negative 3
Times negative
times
1.
negative 1, which makes it, so it's 2 over 1 minus x cubed. So actually, I can find twice what I need. So in order to find this, it's half of the second derivative,
Uh-huh.
right?
Yeah.
So let's see what it is. So it's going to be half of the derivative of that. And what's the derivative of that? 2 plus
6x.
6x, and the next one is going to be 4x cubed.
So 12x.
2
squared.
Fine.
x.
So, but if you get this on the
12x cubed, so 12x squared.
Squared. Squared.
So it's going to be n minus 1, x to the n minus 2.
So we first have to find the expansion of 1/1 minus x squared.
You know it. Oh,
No, we
yeah.
don't know yet.
How can you do fifth derivative without
Yeah.
fourth derivative? I don't know anybody who can do.
So,
Oh, by the
okay.
way,
But it's quick. It's not like you just take the derivative.
can you do the derivative of the seventh without doing the derivative of the sixth? Yes or no?
Yes.
E to the x.
Yeah. That's what-
What are you talking about?
If you e to the x, it's just going to be easier.
E to the x, I can do any derivative.
Did you guys just say yes because you didn't?
No,
yes,
no,
or
e to
did
the
you
x.
actually-
No, you.
No, I actually stopped
Wow.
it. Didn't you?
No, I didn't.
Because you're trying to trick us.
So you
I
knew it
always
was a
want to
trick, but you
trick
didn't
you.
know what.
You know
e
what?
to the x is always
I'm
the
going to
derivative.
trick
Yeah, I
you that I'm going to ask you something that you always think that it's wrong, and then I say, what's the derivative of x squared? And you say, oh, you want us to say, isn't it 2x? And then you won't believe in yourself that it's 2x. That's when already the trick is
30
gone.
seconds. 30 seconds.
Okay, so put pause.
No, it's okay. She'll wait.
She'll wait.
Dial me that or something.
Show me what
Remember, you're being recorded. What?
was your senior. Never mind.
Senior project? I did it already.
What was yours about?
What did I do as a senior project?
Yeah.
I didn't have a senior project. Only in the American school there is a senior project. In the Israeli school there is no senior project.
Yeah, the rest of the world is normal.
Normal.
Logical.
Logical. You don't like it?
Nah.
Me neither.
It prepares you for the life
What?
to be an
That's what they
entrepreneur in the American school. How to make money.
Mm-hmm.
with a senior project.
With everything, yeah. It's like this is the purpose. And also study other things, by the way.
Yeah. No, you sometimes learn life skills in senior projects. Like what I'm doing on like body language and reading people. And once you
Yeah, but the
understand
problem
that,
is,
it's like a
do
life
the
skill.
people in the panel know your subject? That you
Probably
should?
not. But
Yeah,
that's
but
beside
it's
the
just-
point.
That's not the point.
No.
Exactly. All right, can we continue? So, what is the expansion of 1 over 1 minus x cubed? It's half of this, which is actually,
It's 1/2 plus 1
it's
half
going to be
x plus
1 half
1
of this, which is 1 plus 3x plus 6x squared, and so on. Okay?
Okay.
Isn't that amazing that we got 1 over 1 minus x cubed? By the way, you don't have to memorize those two,
No.
because you can get to them. Otherwise, your head will be full of all kinds of information, and you need to actually know how to get to that rather than really remember all those things, because it's too much information. All right, if there is a term-by-term differentiation, you want to see something interesting.
Sure.
Always.
The derivative of sine x is cosine x. So if I take x minus x cubed over 3 factorial plus x to the 5th over 5 factorial and so on, let's see if the first terms coincide with the first terms of cosine. What's the derivative of x?
1.
1. And then minus 3x squared over 3 factorial.
Which makes it 2 factorial.
Which makes it 2. And then I have 5x to the 4th over 1, 2, 3, 4, 5. The 5 cancels out, and I have 4 factorial. And here is the cosine.
Oh, I'm taking a picture of it.
By taking the derivative of sine, you get cosine.
Oh,
Yeah, of course.
I'll read you that.
Yeah, but I
Wait,
mean,
the
you just want to
derivative of-
see.
3 factorial?
It's not the derivative of 3 factorial.
You
Look,
did
we have
3x
3x squared over 1, 2, 3. The 3 cancels out, and I'm left with 2. And 2 is 2 factorial. But here you can see it better, because I have 5 over 5 factorial, leaving me with 4 factorial, because the 5 cancels out, and I have 1, 2, 3, 4, which is 4 factorial. Sometimes you can't see the beginning, the pattern, because 2, you don't know if it's 1, if 4 is 2 plus 2, or 2 squared, or square root of 16, so we need to know more. But here we know already, it's like somebody who has seen the film, and they tell him, okay, so what happened in the second? Is he gonna kill him in the end or not? Okay, so now we know how to get those, and now we will do a term-by-term integration, which is more powerful. The only problem with term-by-term integration is what? Shir. Shir doesn't know the answer. Anybody else?
The problem with it?
The problem with term by term is
Shame
that
on you,
if there are a lot of
We have
terms,
to it's based on memory.
I'll tell you what.
No,
You
it is.
integrate
I don't know what it is.
f of x dx, you get f of x, and you get plus
C.
c. So I get the constant of integration, and we need to see what the constant is. Most of the times it is 0, but sometimes it's not 0. So we will see how we do it. Okay? Ready for term-by-term differentiation, and now look what it is.
Integration.
Haha.
Give up.
Okay? So term-by-term integration, and let's take, the first one that we take is,
Shlomo, it's a very good eraser. Well done.
what do you mean a regular eraser?
Very good eraser.
I know. I'm going to adopt it. Okay,
I will make it mine.
so 1 over 1 plus x, when x is less in absolute value. Do you see this Shir, or is it like more to, shall I write more to the center? She says it's okay. So this is, I'm not going to write in, I'll write also in sigma form, but it is like this. Anybody knows what it is?
Plugging
Oh, LM.
zeros. So
No.
So it's
That's
What?
1 over 1 plus x.
So it's 1
1
plus
plus or
Oh.
minus?
Minus
Minus what?
x
And plus?
x squared
Minus?
x cubed. Yeah, you go
Plus?
on and on.
What's
Yeah.
the...
What?
And it's
'Cause then-
-1 to the n, x to the n, right? Or in sigma form, it is,
But
and
that's
goes...
not, those are not the integrals of it.
I'm not doing integral
Oh.
yet. I'm just writing it out.
Yeah, I thought it was.
I was thrown off.
Wow,
by the
look how
term.
nice each writes. This one really writes some nice. Okay, so I don't want to take the derivative. By the way, if I needed to know 1 over 1 plus x squared, I will differentiate both sides. But now it's more interesting.
Take the integral of everything.
I'm going to take the integral of this. Why am I going to take the integral of this? Because the integral of this is actually ln of 1 plus x. Wow.
Wow.
So I'm going to get to the ln of 1 plus x by integration. The only thing that I'm going to get is plus c. So let's first integrate this. It's going to be x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus -1 to the n, x to the n plus 1 over n plus 1, right?
Yeah.
So it is -1 to the n, x to the n plus 1 over n plus 1, n goes here. I can start from 0 to infinity. Let's see if it works. X to this, if I plug in 0, this is how you check it. The first one is that. Plug in 0, that would be plus x to the 1 over 0 plus 1, it's fine. Now this, do you know how to, by the way, how to change the index? Because if you have, this is like something to do, I taught you last year changing the index. Do you know how changing the index? Of the sigma. This is change of index. So if I have n goes from 2 to 13 of 5n plus 2, this is equivalent if I lower, let's say, if I add 1 to this, I minus 1 from this,
Oh yeah, yeah.
right? So actually, I can actually start at 1. I can actually start at 1 because infinity minus 1 is also infinity. I added 1, so I subtract 1.
Oh.
So does this ring a bell? We did it with the n equals 1 to infinity. And now we can write it also like that.
This is the sign.
No,
No,
this
this
is
is ln
also
of
the
1 plus
same, ln of 1 plus n. Just that the sigma goes from, because I couldn't start the sigma from 0. So if you get this, and you said, no, we got n, x to the n over n, and now it's n plus 1 over n plus 1, but look at the sigma, it starts from 0, the other one starts at 1. It's the same idea. As long as you remember that it's this. But there is a plus c. And I'm going to write the plus c in red, and we will see what the plus c is. How do we determine what the c is? We take x to be 0, and I get ln of 1, right? If I take x to be 0, I get ln of 1.
So
Yeah.
it's 1.
ln of 1 is
0.
0. But if I plug in 0, I get 0 minus 0 plus 0 plus c. So what is c?
ln
No, c
0.
is 0.
is 0. So in that case, c is 0, so it's great. So it's the best. When c is 0 is the best. So actually when we integrated that, this we found actually the ln of 1 plus x in a very elegant way. We're just integrating 1 over 1 plus x. Okay? Instead of doing, we did it last time doing Taylor, which took longer time.
So that's the sigma.
Longer.
The sigma notation for ln.
Yeah, but if you remember that it's x minus x squared over 2 plus x cubed over 3.
Yeah. Okay.
Now, I want to show you something very interesting about the ln of 1 plus x after you. And what's the interval of convergence for this? For the millionth time? X
Okay,
is
from
between
open -1, close
negative 1 to 1,
Close.
but
Open the.
close on 1.
Wait,
Okay.
shouldn't it
Usually
be
that's not for our
from-
answers, but in this regard.
Only the ln,
It's not.
the ln is always because of the Leibniz thing.
No, but from n is equal to 0. I was just wondering.
Oh, n equal to 0 or n equals 1. It's both. You can write this or this. This means alternating with n, and this is, you can write n minus 1, n plus 1, n plus 3.
Oh yeah, no. I
Doesn't
can see
matter,
it.
because this is the alternating factor. Negative 1 to the n or negative 1 to the n plus 1 means it means only one thing. The odd terms are negative or the even terms are negative. That's all. It just changes, it's the alternating factor, negative 1 to the n or n plus 1, according to what we want. Okay, I'm going to erase this, and from now on I'm going to show you tricks how to find expansions of Taylor series. As I said many times, that we learned the classical way, which is the longer way. It is like solving a quadratic equation by negative b plus minus whatever,
Finding
but
the limit instead of
they're
the-
shortcuts. And the shortcuts are very tricky and sometimes are so nice. And I will show you so many things. You're going to have a lot of things to remember. But if you don't remember this in the test, there's always Taylor method. So it's a matter of time, it's a matter of energy, frustration. You can imagine if you have to do something
you can
that...
always check if you have extra time. You can.
Yeah,
Yeah.
you can. Okay, so let's look at the ln of 1 plus x, which is x minus x squared over 2. No factorials. In ln there are no factorials. Plus x cubed over 3 minus x to the 4th over 4, and so on. Now I want to show you something very interesting. Every lesson you have something things that you knew before, and now you see
Wait.
it in a different perspective.
Shlomo, it's negative x in the beginning.
No, it's positive x.
If you plug in 1
Yeah.
to the thing, you did. Oh, wait.
No, he's
ln of 0 is 1.
Yeah.
ln of 1 is 0. It's fine. It
Yeah.
starts with an x. Never with a negative x. Okay. So, let's plug in 1. If I plug in 1, I get ln of 2. First of all, if I plug in x equals 1, can I do it?
Yeah.
Yeah, you
Is it in the radius of convergence?
yeah.
Yeah.
Because it includes the 1.
Yeah. Yeah.
So ln of 2 would be 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5. Now look what happens. If this is 0 and this is 1, I'm going to show you something super
It
interesting.
will never reach 1.
If I go 1, I minus half from it, so I'm here. Then I add a third to it. Then I minus a fourth from it. Then I add a fifth to it, and a sixth to it, and a seventh to it, whatever like this. And this number will be ln of 2, which is 0.693 more or less. Now I need somebody to do some approximation
But actually,
in the calculator. Could you do the sigma of this? Negative 1 to the n, x to the n over n goes from 1 to infinity. Let me see if it's like, no, it's n plus 1. Let me see if it's true. If n is 1, it's a positive. If n is 2, negative 1 to the third x squared.
Wait, you
Oh,
can't-
no, we don't need to do x.
Wait,
Just
there's
write
an
this.
X. Yeah, there's
Just
an
write
X.
this.
From 1 to
And let's
Should
say
we
from
just
1
put
to
like-
10.
1 to
And
10.
then we'll do 1 to 20. Let's see how much. How are you falling asleep?
No, I don't know, man. It's not because of it.
Is that to the
One
n
day.
plus 1
Yeah, to the n plus 1.
over
N. What did you get? 0.6.
0.645.
0.645. Okay. If 10 terms, you get 0.6.
4 or 5.
4563.
Doesn't matter. It's already not good. Okay. Can you do 20 terms? Yeah, it converges very
Point-
slowly.
0.668.
How
looks-
can
yeah,
you
that
change
looks
it already like this?
Huh?
How did you change it so fast?
I just copied it and then changed the 10 to a 20.
Okay, show me how you do it. It's like really. How do you copy this?
It only works on some calculators, but I just press up and I click on it and it's
Yeah.
there again, and then I just change the 20
Oh my god, this is
to
so.
whatever you want.
Okay, so to 20, how much? 0.66?
0.668.
Can you do 50 terms?
0.683.
100 terms?
Whoops, that's 10. 100 terms is slow.
Yeah, it will.
0.6881.
What?
Yeah, I don't know what's happening.
881? No, it can't be 881. It's even worse than this. Are you sure?
No, 881.
It makes
Oh,
sense.
881, sorry. Can you do 300 terms and we'll stop here? It goes very slowly because this is like very slowly until it goes.
0.6914.
Wait, a little bit more. Let's do 500.
You know what? Do
1,000.
1,000 terms. It'll take a while. Well, we have time. Can you rush it, please? Can you?
0.692.
0.692.
6. Yeah, 0.6926.
Wow. And ln of 2 is 0.693. Can you find what ln of 3 is? Even 1,000 terms, it goes very slowly.
ln of 2 is
0.693.
0.69314. Yeah.
Yeah, wow. Even 1,000 terms is not enough for this. But I'll show you why. Because the function is at 0, ln of 1 plus x, and we want approximation for 1. It's far from 0. If I wanted ln of 1.02, it will be super good approximation even after 10 terms. Let's see. Let's find the ln. So what I want you to do is tell me what is ln of 1.02.
So it's okay.
Just tell me what the exact value is.
It's
It's
0.0198.
0.0198.
198.
And after 98?
No, 0.0198.
And
Yeah.
after 8?
026.
Okay. Now, what we're going to do instead of 1 is going to be 1.02 to the n. Okay? And take it from 1 to 10. Just let's see how close it is. The others even, just write instead of 1.02 to the n. You change the
Okay.
sigma. Because the other one was 1 to the n, so we didn't write anything.
To the,
Let's see how close. That's only 10 terms.
in just 10 terms. Will
Yeah,
be
from 1 to 10. The other one, 1,000 terms was a bad approximation. Let's see, 10 terms, how much?
It says 0.644, but that's not right.
No.
Why is that? Negative 1 to the n plus 1
Yeah, times 1.02
all over x.
over, yeah.
Yeah.
Are you doing parentheses after this, like this? If you don't, then you won't understand what you want.
Does
Yeah.
it help?
No.
Ow.
No, it's not working.
Let me try again.
Huh?
From x,
I don't know our books. So
from
I
0,
don't
No, from 1.
Sorry, from 1 to 10
know.
of
Food?
Negative 1 to the n plus 1 times 1.02 to the n all over n.
time
After this, we'll take a 2-minute break.
1.02 to the n.
Oh, okay. I don't need 2 minutes.
Okay, over.
Your Korean.
Yeah.
So, you're racist.
Korean.
You sure?
Breaks.
You're Israeli.
Yeah, because I'm
those
doing-
breaks.
Don't you replace the.
Wait a minute, I think it's 0.02. Oh, wait a minute. I think it's 0.02. Ln of 2 is you put 1. Oh, I got it. It's 0.02 because it's 1 plus x.
Oh.
Yeah, because it's ln of 1 plus x and 1
Oh.
plus 0.02.
Oh, makes sense.
Yeah.
Makes sense.
Okay, because then it would be 2 point
Yeah.
something.
So it's 0.01980.
Wow, it's already
What
good.
do you
Yeah.
think of my
026.
It's only
quite
10.
good. Yeah.
Yeah, it's only 10, and the other one was 1,000, and it was like so off. Okay, 2 minutes break.
Me,
Oh, wow.
So we learned integration. We learned
Is this how I read it?
Huh?
Mikael. Is this how you read it?
no with a cuff.
This is a cuff.
No, that's a cuff.
Oh, cuff. See.
That's makil. The yud is after the mem.
Mikael.
That's mikil. It's aleph between the kaf and the lamed.
Me,
Yud, kaf.
I'll be back.
me. Kael.
Yeah. Yeah, like this.
Oh yeah. No, that's H.
Miha. There's no ka.
Mikael.
No, ch. There's no ch.
Mikael. Okay.
There is a ch in Korean?
Yeah, it's H.
Yeah, micha.
No. Yes. No.
Wait. Oh, like this. Or like this.
Yeah. Yeah, but like that. This and this makes the same sound. This is all
Michael. Michael.
Michael.
Wow. My Korean is.
Pretty good. Did you like this speech contest?
Oh, I loved it, yeah.
What was your favorite?
I think Fiona.
The thing
Wait,
is,
Gibbon, his name is Gibbon or Gibbon?
Bomb, the second.
No, Gibbon with an
Gibbon.
H.
No, it's K.
Oh, it's Gibbon.
Shlomo, I did 3 hours of exercise today, followed by a very big meal.
Yeah,
This
so
all leads to sleep.
Any meal.
Human nature. Exercise, eat, sleep.
so
In that order.
Don't justify you.
So I'm
falling
fighting.
I can.
struggling. Like I'm cleaning the board like it never was before. Like look how clean it is now. So no signs of LNs.
No, Fiona's was good, but the topic doesn't interest like everyone. You know what I mean? It's
Why
environmental
not?
science.
I mean, it's like she's from Montana, right?
Yeah.
But we can't relate to it.
Exactly.
Is she Waylon's
Yeah.
daughter?
Yeah, it's Fiona Whelan.
Oh, okay.
Eve was,
No, let's
No.
be honest.
if she would have been less dramatic,
If she had been,
if she had,
she would have.
if she
You
had
can't say
been,
if she would have.
if she had been less dramatic,
Yeah, it was too
And-
dramatic.
the way she said
The
some
voice.
of the words were,
No, but Courtney was really good.
Courtney
It
was
was good.
amazing.
Yeah.
No, in the beginning, the introduction was kind of lame, so I was like, oh, kind of lame. But then it was so amazing. I was like, whoa.
yeah.
But like, I don't know. You
I wait, there's a blue whale or there's a blue shark?
blue whale.
Blue whale?
Eve
What's the
was
color of the blue whale?
black.
Yellow.
Yellow? Wow.
Oh, really?
So why are you calling it blue?
The thing is, Eve's like it was nice, but the context wasn't that great, to be
Yeah.
honest. She's a really good public speaker, but the context was I was like,
And I didn't like the idea, please rise. It was out of.
to be honest. And then her voice, like I don't like how people change their voice for the speech. You know what I mean?
Yeah. I don't know.
But she was a really good public
But
speaker.
Gibbon was like, he was speaking like a. What the idea? The idea that he spoke like a.
Motivational speaker.
Yeah.
Yeah, that's what.
But he spoke like a southerner.
He copied a motivational speaker. What's the name of that? The workout guy.
C.T. Fletcher?
Yeah.
Who?
C.T. Fletcher.
I'm gonna watch this. What's his name? C.
I thought Nabil was good. It was good. I thought he would win. Like
Wait,
he's the
CT?
third
How do you spell it?
place.
C.T.
Yeah.
Fletcher. So Fletcher.
CHER.
I thought he would get the third place, Nabil or Tess, either one.
Tess was good. I liked
Yeah,
it.
Tess was good. I liked it. The last one was just like so funny.
Tess was on. What?
Lying.
Oh, lying. Yeah, it was nice. It was interesting, by the
The
way.
last
The other speeches were weak this year.
so
thought they
weak
were
this
really
year. The last one.
I hated the most with Nabil, the other Nabil.
Oh,
Lots of them.
I
Well,
couldn't
they didn't
relate
say
to this.
anything.
I
No,
like
the first one was
Black
ridiculous.
Friday.
Yeah, let's be honest.
The Black Friday, I like it.
Yeah,
Let's be brave.
he was
Oh,
terrified, that
stand for-
kid. Yeah.
He's
On
like,
stage, he was
Honestly, my
shaking.
speech is so much better. I think they should pick more from seniors.
No,
'Cause I don't know.
Brave and Nabil were not the other Nabil. The Black Friday was very interesting.
Yeah. No, listen, 3.
And there is
The
really
first,
Black
the brave
Friday.
guy, the argument guy, and the successful guy. So 3 were the best this year.
Yeah, the success is like, come on, let's be ourselves.
And Eve presented it well, but she was saying nothing.
The context was really bad.
She was just saying, "Don't give up, don't give up,
Guys, don't give
up,
up.
don't give up."
No, the thing was really important. Like, it
Wait,
was
but they make up the speech as well, or is it like they copy the whole? They have to really.
No, they wrote the speech,
They wrote the
they
speech.
read it and
Everybody
they
wrote-
presented in class, so the classmates
and then
picked.
the class like decides who the winner of each class is, and then they go to.
Oh, you mean what class?
Like
English
English class.
class.
Your English.
So
oh,
like
so
Kibam,
it's
one
not the
from our
teachers.
No, Kibam won from our class, and so he goes to the next round.
There used to be the second round for like teachers. Like they
Yeah.
dropped like 3 or 4 people, but this.
What
year
was
they
yours?
didn't have it.
this
On
year,
food?
it was very
Any
bad.
meal.
About what?
Oh,
Let me guess.
Yeah, let's
You
guess.
won't- you won't
Give me
guess.
You're not
three.
gonna guess.
Give me
You're
5
really
things, and I'll tell you what.
What if you don't guess? You
What
just
was
go-
yours?
I know you.
No,
Give me
Eve's
five
was
don't
kind
know,
of
it's
bad.
so long.
Eve's
You
was
trust
kind
me,
of
right?
bad.
Wait. Give me 5 things, and wait.
Okay.
You probably speak about. Okay, go ahead. Give me 5 things.
last
No,
Give
year-
me 5 things.
give me 5 things. I'll tell you what you chose.
Just
100%.
5 words.
No, 5 things make up 1 right and 4 wrong.
Oh,
Fine. Why startups are, why every teenager should make a startup?
Okay, that's number 1. Number 2.
Okay. Why the business world is cruel?
Okay, number 3.
Why math sucks?
Number 4.
Why math is the best topic of all?
Give me 10 then. 5.
he knows the
5.
answer already.
Every person should learn computer science.
Yeah.
Every first grader should learn how to code legally.
Yes,
No.
really.
Program.
No.
Why concerts are the best? Why classical concerts are the best?
Okay.
Why old people should be banned from classical concerts?
That's
This I think.
Yeah.
Because this is something that because you always like to do something which is controversial.
yeah. Actually.
No,
Like
last
to
year I
throw a
did.
bomb.
No, last
Last
year
year
was
it is.
last year was
The last one.
nice.
Last year I did why.
Oh, because they open all those
Yeah.
candies and they
Yeah.
cough a lot and they what?
Wait, did I tell you about this speech before?
I go to concerts and I know what it is.
Those are exactly my
And
points.
why they and I hate when I go and they go on the stairs and once I fell because they were going
Dude, this
and
is
they
a
block
speech.
this.
Did you
And
So I probably told them like 2 weeks ago.
No, I don't go to concert. I mean, come on, it's 79 is the average. The median is
these
85, and
These are my 3 points in my speech.
and they go like this, and they don't care, and they fall asleep, and then the wife would say it's like, and then they go like this because when
He knows me. What the fuck? Shut up.
I've been to concerts more than you.
I don't know, man. How do you know like my exact points?
No, because whoever
Is it
goes
true?
to a concert knows that the old people, what they do is they put a ton of perfume which smells a little bit like those in the toilet. And because they put this and it's like a happening, they climb up the stairs to the 32nd row.
Wait,
They
so-
sit where they are and they just like, and then when there is the intermission, they go for the coffee and they line up over there and they come back. Oh,
Wait, so you're not gonna go to concerts when you're old?
no, I'm just saying I'm not saying good or bad. I mean, this is a fact.
Oh.
Whether you like it or not.
But
They cough like crazy. It's like something is stuck in their throat. It's just like in between.
I don't know.
Everybody coughs like
so I wanted
crazy.
to make it like a satirical speech. a joke, but nobody laughed. It was really sad.
No, because this is something that you can't laugh.
Yeah, it's sad.
Because it's
It's
something
gonna
that
happen
you
to
cannot.
you.
It's like you do something racist and everybody will laugh. You know what I mean? It's something.
But I thought I was saying it in a way.
It's
that
called
was
the
funny.
Hebrew parak dosha. There are some things you cannot laugh even if it's
Funny.
Yeah.
So I guess this was one of them. I learned
like
that
if
hard
you
way.
if you make a comment about racism and you really want to laugh and you know if you laugh that means you are one of them. So you will keep your mouth
But I
shut.
was being like very satirical. I was being very extreme. So I thought it would be funny, but no.
Okay. Right. So let's continue with our stuff. And we did the ln of 1 plus x. Now it's time for. Do you think Meshane Makom, Meshane Mazal?
Yeah.
We started off with left ברגל שמאל וביד שמאל. Okay. What's the expansion of this?
We know how to do this because we know 1 over 1 plus x.
Yeah.
And then
Yeah.
you just plug in x
So it is going to be.
negative 1 to the n.
No, it starts with 1.
No, you
First
want
of all, we
to.
have to do one
Yeah,
over
it's like this.
It's x minus x squared plus x cubed
I
minus.
know, but I
It's
thought we were
not
doing
x
single
minus
notation.
x plus x squared minus x to the third, and now the x squared becomes the square
Yeah,
to the
square is
fourth.
4.
Okay?
Wow. Why? Oh, because it's squared. Why?
So it is negative 1 to the n, x to the 2n. You agree? And it goes from 0 to infinity. We're missing something. The radius of convergence is
It's all real numbers.
Absolute
From
value
negative 1
x.
to
absolute value less than 1. Because it comes from 1 over 1 minus x. So, if I take the derivative of that, it's not interesting. But if I take the integral, what do I find?
It's gonna be something with ln.
It's going to be arctangent. Very good.
Yeah.
The arctangent. Now, I can find the, actually, the arctangent of x. If somebody tells you find, you don't want to write anything? Find the power series for arctan. So you say, oh, I don't feel like taking derivatives and Maclaurin and all that stuff. So I know that it's the integral of 1 plus 1x squared. And I know what this is. So let's integrate it. So it's going to be x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 and in sigma form negative 1 to the n x to the 2n plus 1 over 2n plus 1. No factorials. Let's see if it starts at 1. And that's how you check. If x is 1, x is 0, then I get x over 1 and it's plus. And let's say x is 2, n is 1, so I get negative 1 to the 1, x to the third over 3, which is negative x cubed over 3. So this is right. Okay? So this is arctan. Wow. So now we know the arctan. Why don't you add it to your list? Not to memorize, but to know how to get that. So for as far as I'm concerned, if somebody tells you find the expansion of arctan, you know that you do 1 over 1 plus x squared and you integrate. But I missed something here. What did I miss? The plus c. Let's find the c. Let's take x to be 0. Can I take x equals 0? Is it in my radius of convergence, my interval of convergence? Yeah. So arctan of 0, which is 0. So all of them are 0 plus c. So the c is 0. Luckily. So actually, we don't need a c. It's itself. All right? But always don't forget the c.
Okay.
So now we know arctan. So can
Yay.
anybody tell me what is arctan of 2x? You plug in 2x. It's going to be 2x minus 8x cubed over 3 plus 32x to the 5th over 5 minus 128x to the 7th over 7 and so on. You plug in 2 in
Wait, that's arctan?
Yeah.
Isn't that the same as... Oh, it's the same as sine without the factorial.
Yeah.
Yeah.
It's like the sine without the factorial.
Yeah.
Very good. Yeah, it's like the sine without the factorial. Wow, I never. Actually, it is exactly.
Yeah.
Because the sine would be with the factorial here, and it's from 0 to infinity, making 1 to the n. Wow, I've never seen it like this, really. No, I'm not being sarcastic.
Okay,
Because I've been doing it many times, but I never looked at it like a sine without a factorial. So what about the ln of 1 plus x? Does it remind you of something? What was it? N goes from 0, negative 1 to the n plus 1 x to the n over n, right?
Yeah.
Oh, it's like e to the x because it's x to the n over n factorial. It's like e to the x just with a negative 1 without the factorial and with a negative 1 to the n, right?
Yeah, but that's stretching it.
Yeah, that's too much. Okay, fine. Right. Let's do some calculation work, approximation work. So, let's take... Oh, we can't take 1, because arctangent of 1 is pi over 4, but 1, I cannot take 1 here, right?
Pi over 2.
No, because if I take 1, arctangent of 1 is pi over 4, but I can't take 1.
Yeah,
So do pi over 6.
but if...
Or arctangent of
Pi over 6.
square pi over 6 is square root 3 over 3. Let's take square root 3. Okay, square root 3 over 3. Let's take arctan of square root 3 over 3. The answer should be pi over 6, right? Pi over 6, right? So if you plug in pi over 6 minus pi over 6 cubed over, well, it's too much work for you. If you put pi over 6 in that will get to more or less square root 3 over 3, you'll get, fine, let's forget it.
Okay.
It's not worth it.
Thank you.
Okay, now we're starting something that you're going to love. And the next topic is, we did the integration both sides, we did the term by term differentiation, term by term integration. Now, can you sit?
I'm learning here better.
And you?
I'm gonna sit down.
Okay.
If I sit, then I'll fall asleep. If I sit down like this, then I feel like I'm active.
Are you sick?
Okay. Let's see. By the way, if I give you something like this, f of x equals 2x cubed minus 5x squared plus 7x plus 5. And I say find the Taylor expansion for this, the Maclaurin. You will get the same thing because you will get itself. You will get a0 is 5, a1 is 7, because if it's a polynomial, then it will give me all the coefficients and all the rest are going to be 0. Okay? So that's not interesting. So how do we multiply? Last time I showed you how to multiply 3x squared minus x plus 2. That's multiplied by x squared minus 7x plus 1. We do it by this. We write the first one is 3x squared minus x plus 2, and this one is x squared minus 7x plus 1. So we go 3, negative 1, 2. And here we go 1, negative 7, 1. And we find the numbers inside. So that will be 3 times 1 is 3. That's negative 21.
Oh, we did this last time.
3, yeah, I know, but it was the end of the lesson. So that would be 7. That would be negative 1, 2, negative 14, and 2. And then we take like this. We write 3, then negative 22, then 12,
Negative 15.
negative 15, and 2. And we go x, x squared, x cubed, x to the 4th. Now, in infinite series, we're going to go backwards. We're going to write it from, not from the highest to the lowest, because we don't know what the highest is.
It's infinity.
Yeah, so no, but I mean we go from the smallest to the biggest.
Okay.
So in that case, if I have something like that, I would write it like, it's like
I was
2
gonna
minus x plus 3x squared, because times 1 minus 7x plus x squared, because it goes like this. So I go 2 minus 1, 3, and then I go 1, negative 7, 1, and then it will be this will be number x, x squared, x cubed, and x to the 4th. Okay? So now let's have a look how we want to find an Taylor expansion for in other words, find Maclaurin series for that. Okay, of course you're free to do first derivative, second derivative, and I show you that the second derivative, no human being can go further than the third derivative because it becomes so tedious, right? Just to tell you that the second derivative, the top becomes, it's like, it will be something like this. The top will be, the derivative of the top is a product rule, times the bottom, minus the bottom, and you can imagine that's already, it's terrible.
Yeah.
Very tedious, and it's, I mean, you can't appreciate. Do you want to see the second derivative, how it is, or you
No,
already
We
picture?
understand.
Okay, so there is another way to look at it, and it's a super simple way. The f of x is actually e to the x times 1 over 1 minus x. So we know the e to the x, and we know this. So let's look how it is. E to the x we put here, and 1 over 1 minus x is here. Let's write the first terms of e to the x. It's going to be 1. In e to the x, I'm going to write here 1 plus x squared over 2 factorial plus x to the third over 3 factorial. I'm going to write 3 factorial like 6. And let's do another one even, plus x to the 4th over 24, 4 factorial. And 1 over 1 minus x is 1 plus x squared plus x cubed plus x to the 4th. Okay? That's already even a lot. So let's take the coefficients. It's going to be 1, 1 half, 1 over 6, 1 over 24. Because it's an easy problem, I take even 4 terms.
Okay.
5 terms of it.
1, 1, 1, 1, 1, 1.
Yeah, 1, 1, 1, 1, 1.
Wait, the first one is a 1?
Because it's 1 plus x. Okay, let's see. You know what? Let's stop here. It's just like, it's fine. The idea is they won't give you. Okay, so this will be 1, 1, 1 half, 1 6.
1, 1, 1 half, 6.
Oh, all of them are going to be like 1, 1, 1 half, 1 6. And 1, 1, 1 half, 1 6. Okay, so we have 1. Then we have 2.
Yeah. 2.5.
2.5.
2.8.
How can you get 2.8? Excuse me. 2.5 plus 1 half plus 1 6 is 2 thirds.
6,
Oh,
which is 2
so
thirds, which is 0.65.
So 2.6 bar.
2 and 2 thirds.
Yeah.
Okay, we're going to write it like this. We don't like this. This is 5 halves. And this will be 8 thirds. Okay, we'll do it in fractions. Then 1 half plus 1 6 is 2 thirds. 1 and 2 thirds is going to be 5 thirds. And then
2 over 3.
2 over 3.
1 6.
Oh no, actually no, it's not right because there are also
Yeah,
things
more.
from here.
Yeah.
So up to here, we have to do it like, always do it 3 by 3 or 4 by 4. We did 3 by 3, so we got this. Because then it goes up to here.
So erase the 8 thirds.
So let's do this one. We erase the 1 and 1 6, right? So this one was 2 and
2, it's 8/3.
8/3, and we'll stop here. Because
Okay.
in order to find this, we have to, so it's enough like this. So it's 1 plus 2x plus this x squared plus this x cubed. No need factorials because this is already, it's not like the Taylor formula. This gives me the final thing, okay? And I don't know if you appreciate it, but if you took the second and the third derivative, even the second derivative, to get this, it'll take forever. And the third derivative, you will never get to that because you will just stop after the second derivative. It's like too much for human beings to go on. Okay, and here I can do another one. It's no big deal. I can do another line. It's just adding 1/6 and plus 1/2 and this. What's the big deal? This is not something you can give it to somebody from middle school to do the busy work. Okay, so that's about it. Now we found the e to the x over 1 minus x just like that. Okay? Let's take another example. And the last example for today. Is this nice method
Yeah.
of multiplying?
How was it with Ella?
Fine, good.
No?
Bless you.
Thank you. Punch it.
Okay, e to the x times cosine x.
Okay.
You know what? The first 4 terms will be more.
Hey, we know how to do both of them, so we just split them up. And when we do multiplication rule, Shlomo.
So then e to the x is
No, but you multiply without the x times.
so e to the x is 1
E to the
plus x plus
1 plus x squared over 2 factorial plus x squared over 3
Six.
factorial plus
No,
That's
1/6.
6.
1/6.
and then 1 over
You
24.
said first 4, no? So isn't that it?
That's 3 factorial. Oh yeah, okay, but what's the next one? Just
1
in
over
case?
24.
1 over 24. Just for
Just for fun.
yeah, and this will be 1. What's after the 1? 0, because there is no x. And then there is minus 1/2, because it's like
Wait, how are we
1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. So there is going to be a 0.
Why is it x to the n over n factorial?
No, because it's only the even ones.
But x to the n over n factorial. Right?
Negative 1 to the n, x to the 2n over 2n
Yeah,
factorial.
2 over
X to 2n plus 1 over 2n plus 1.
No, the cosine, come on.
cosine.
I'm looking at cosine. Oh. X to the 2n over
Then look closely. Okay? Let's do this. This is 1, 1,
1/2.
1/2, 1/6, 1 over 24. The 0, that's
0,
very
0, 0,
top.
0, 0.
This, negative 1/2, so it's negative 1/2, negative 1/2,
1
negative 1/4,
Yeah.
negative 1 over 12, and negative 1 over 48, if we ever need it.
0, 0.
And the 0, 0, 0. Okay, this is definitely going to be, if it goes up to the point, this is 1. After it, there is 1. After it, there is
0.
a 0. After it, there is 1/6 minus negative 1/3.
Yeah.
Yeah, and we stop here because then, oh, okay, we can do this. 1, 0. Oh, we can do this. Okay, another one. 1 minus 1/4 is 3/4. 3/4 plus 1 over 24 is 24.
18.
It's 18, 19 over 24. So 1 plus x, no x squared, x cubed, and x to the 4th. So it's 1 plus x minus x cubed over 3 plus 19 over 24 x to the 4th. These are the first terms of e to the x cosine x. But why there is no x squared? It looks very weird. Is it 1/2 and
Always
negative
look on the bright side of life.
x squared over 2 factorial? Wow, it is. You know what? Let's see if the second derivative becomes 0 and with this would be the last. So this is e to the x cosine x. Let's do it in. Let's do the long way, just for the.
No.
No, I'm gonna do it. Just you're gonna look at it, okay? E to the x cosine x. That's f of x.
Is that from Monty Python?
Yes.
Genius.
Okay, the derivative of the first times the second plus the first as it is. So e to the x cosine x minus sine x, right?
This one is not that tedious.
So, second derivative, the derivative of the first times the second, plus the first as it is, times the derivative of the second. So it's cosine x minus sine x, minus sine x, minus cosine x, which is negative 2e to the x sine x, f double prime. Yes, it is 0, because that makes it 0.
You don't take a picture.
Yeah, because sine x makes it 0. Wow.
But our first two
unbelievable.
terms are 1 plus x, so it doesn't work.
No, the second, this is 1, because e to the 0 cosine of 0 is 1. Then the first derivative is 1 times 1 minus 0 is 1. But the second one, the x squared, is 0 because of that. No, the first two terms, that's the 0. That's f of 0 plus f prime of 0 times x. And there is nothing, which is f double prime of 0.
Yeah.
That's a third term already.
Interesting.
Very interesting. I didn't even think
Okay,
about
let's talk about life for a bit.
Wow, this is like, it's, I feel like workout. This is a workout, brain workout. Isn't it?
Okay.
It's more challenging than AB?
Yeah, I mean,
Really?
For
Do
me.
you think the guys in AB doing now related rates and they said it was a super hard
They did
question?
optimization. It was
Yeah, and you know what the problem was
That
in
was the worst
optimization?
thing.
It was this.
No, we weren't able to solve it.
No,
I wasn't able to
optimization
solve.
was the worst thing from AB, I think.
No, I
Everything-
think it was
Definitely.
okay.
Yeah, I think that was the worst.
Oh really?
Why do you think I can't solve it?
You can solve it, we can't. We weren't able to.
You have to, because this is like you do the perimeter, the area is going to be x and y, so it's going to be xy, plus, if this is x, then the radius is x over 2. So plus pi x over 2 squared, but it's a semicircle. What's the big deal?
Yeah, but then what do we do with that?
You maximize it.
How do we? Yeah, what?
You
I
do the
forgot what it
derivatives
is.
set it equal to 0 and so on and so forth.
You do the
just-
derivative.
Yeah,
and
but the
then-
y, you have to, they give you that the y is twice as this, so it's going to be 2x squared plus pi over 8 x squared. So the derivative is 4x plus pi over 4x, set it equal to 0. And so on.
Uh-huh.
If there is anything like
Let's do one more.
one more, no time.
Let's do
No
e to
time.
the x sine x.
No time. Same thing. Basically.
What do we do e to the x times x? This we
Let's-
don't need this
We
because
just
we
do
have.
a product rule.
Yeah, no, it's just like you multiply by x. That's all. But if it's like an infinite series times it,
Why? Because e to the x is just.
no, if it's x times, you just do, if it's e to the x is 1 plus x squared over 2 plus x cubed over 6, then x times it will be x plus x squared plus x cubed. You just multiply by x. No big deal. And actually what I do is like 1 and all of these are 0. Why should I have
So does the AP expect us to know the like this like shortcut?
no,
Like,
you have to, no, you have to do it the long way, and you will do this.
We'll show them.
I don't think it's in any book they have this.
Really?
There are 7 books.
Did you invent this?
I looked at it. I always teach it like this because it's like I think it's a very
Wait, so they
visual
they
thing.
also don't teach you by terms?
No, they have.
So they expect you to do the whole thing with 10.
No, they give you 3 terms, and you do it in Taylor.
Wow.
Yeah, it's annoying.
So no matter what, so they're not going to give us ugly numbers. They know that we have to do it in
It
Taylor.
doesn't matter. 3 numbers. It's if you have a calculator, it can give you the ugliest
No,
number.
it's not looking at that.
So this is it.
I believe.
Okay, next time we're meeting on 12
What's the 12?
because we don't
That's
have a
my
lesson.
birthday.
It's your birthday, okay.
Hey, happy birthday.
Not yet. 1 week.
Okay.
And
Oh my god.
homework will be sent.
But give us something.
Via Facebook.
I'll send it in Facebook. Because tomorrow I'm not gonna be here.
You are
Like,
gonna
tomorrow
be
is
here?
Friday, right?
Yeah.
And then Monday. This thing is like crazy with the drugs. It's so not the right time.
It's good for me. I sleep there.
No. It's like it's very good for me. I take drugs and sleep there. I'm gonna be drugged anyway. And I'm
Is
gonna
it like
sleep there.
Kaif level in the game?
The embassy.
Right, can I have a gum?
Yeah.
It's Michael's.
Yeah, yeah.
Oh, okay. It's after this lesson I need to go. There's no more.
Yeah, there is.
Oh, יש לזה גם כזה, תראה. יש לזה כיסים. תראה איזה השקעה. There's one half. I took
And that's why it's so expensive.
why is it expensive? בגלל זה? Do you recycle, אתה משתמש בזה פעם שנייה אחרי זה? בזה, אתה זורק. מה יש
You
לעשות?
can have the box.
What can I do with it?
Art.
Art? No, I don't think I have anything to do with because it's inside. It doesn't. Oh, God. Wow, what a lesson.
Okay.
If I leave the board and somebody looks at this.
Yeah, let's leave
I
it.
don't think they want
Oh, you have to. Wow.
Enter.
Are you guys done?
Yeah.
Are you staying?
ענבל, תראי את הלוח.
I was like thinking about it.
No, you were.
That's what you're learning. I can
No,
learn
not
that
in
as I
basketball.
Oh, I had to.
I was
It's
figuring it out,
embarrassing.
right?
אתה צריך לכבות את ה... זה לא הקליט דרך אגב.
Matthias,
Wait.
is it still
It's
working?
record.
Is it still working?
Hi, it's so funny.
Is it still working?
I really love that we can make these jokes. Great, they're so fun.
Can we go?
You like it?